Okay, so signal will be transmitted as series of bits, or symbol. Simple example. So in a simple example, we imagine we have only two bits, 0 and 1. Right? Of course, in the digital we cannot have more than this bit, and this 0 and 1 will correspond to something physically. It has a physical representation. So it will have a like plus voltage, and A, imagine it has a minus voltage. For example, it's a 2-bit constellation, 0 and 1. So one constellation will be here. Okay, which will, okay, this we are assuming this is A, another will be here, minus A. So minus A is actually 180-degree phase shifted to A. Right? So this is actually our information. Information bits or information symbol. Okay. Now this kind of mechanism we call it BPSK. BPSK, binary phase shift key. Because we have only two constellation in a binary. Okay. Now, what was our transmitted bit previously? Remember, 0, 1, 1, 0, 0, 1. So how do we represent it? So A minus A minus A minus A. If A represents to 5 volt, then 5 volt minus 5 volt minus 5 volt, 5 volt, 5 volt minus 5 volt. Okay, this is the way it will be distributed. Now how we transmit this this signal? We transmit the digitally modulated signal or bits, whatever, using pulse. This is the way we transmit a signal. How does this pulse looks like? This pulse looks like this, right? This is our one pulse, right? So in this pulse, the say this pulse is P, T, which is a time dependent signal. Actually here T is here. Its amplitude is 1, for example. It has a duration. Duration is T duration, means P by 2 minus P by 2. This is a pulse. How do we transmit this digital modular symbol? We transmit the digitally modular symbol using a pulse. So imagine our pulse is termed as a PT. which has a height 1 and has a width of t from minus t by 2 to plus t by 2. Now, what is the characteristics of this pulse pt? It has a characteristics of what? 1, amplitude 1 at what duration? If t is less than t by 2 or otherwise is 0, right? It's up to this point, right? Otherwise this pt is 0. Now if we express our previous symbol, this one, with this pt, what will happen? We remember our transmitted signal is 0 1 1 0 0 1. So 0 1 1 0 0 1, that is our transmitted signal. So we know, so 0, which is actually a minus a minus a minus a. So let us transmit this signal or shape this signal, right? This is our first pulse, 0. It starts from minus t by 2 to t by 2, which have a amplitude a. Amplitude a. Okay. This amplitude a, this signal is first is amplitude p0 with pt. This is signal. If it's 1, amplitude 1, amplitude will be its 1. Here amplitude is a. Okay, the first symbol. The second symbol start from minus plus t by 2 to up to this. This is 3t by 2, which is minus. Again, the third pulse will be minus 3 by 2 to up to this 5t by 2, right? Then a 5t by 2 to 7t by 2, right? This way. So we're assuming the first symbol is a0. The first symbol is a0. This is multiplied by the original pulse pt. So the result will be a0 pt. But the second symbol is shifted by t, and then the symbol is multiplied by the shifted pulse, right? So the second pulse is a1 multiplied by the pulse itself, which is shifted by t. So this was our first pulse, it was shifted by t. But the third symbol shifted by 2t. Fourth symbol shifted by 3t, right? So what should be the third symbol? A2 pt t minus this one shifted by 2t. So 2t, this way. So if we want to find the kth pulse, so kth pulse will be kth pulse will be shifted by kt, will multiply by its symbol, right? So we write the kth pulse will be ak pt t minus kt. This is the kth pulse represented by this way. So what is the net or total signal is transmitted? So net transmitted signal, transmitted digital signal, actually digital signal is what? Imagine we write it as xt. Xt equal to, we have to sum all the signal, right? So we have ak signal p t t minus kt. This one, signal. Here we have to write the value of k equal to minus infinity to plus infinity. So all the signals are summed. So this transmitted, net transmitted signal will be summation of the all the signal. Right? This symbol, this symbol, this symbol, this symbol, and all the other one. Got it? So this is the typical transmitted digital signal. Okay. Okay. Now we know the transmitted digital signal, where we have the symbol and how much it is shifted, right? Okay, now for kth bit, we don't know whether the kth bit is 0, 1, 1 or 1, right? Imagine if it's 0 or 1, it can be anything, right? Kth bit means ak can be a or I mean plus a or minus a. This a, plus a and minus a, these are random. It's a random value. This is a random value. Now we want to characterize the spectrum of this transmitted signal. We want to characterize x t. We want to characterize this one. We want to characterize this signal. What does it mean? We want to know what kind of signal it is. What is its pattern, blah, 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 all these things, right? The Fourier transform of this signal pt. We need to know the Fourier transform of this signal pt t. What will be the Fourier transform of this signal? pt will be p f, right? pt f. This will be its Fourier transform. Means from time domain signal, we want to convert it to the frequency domain signal. Okay. So what would be this? This is a pt is a square wave, right? Okay. How it looks like the Fourier transform? If we convert it to a Fourier, what is its expression? It's t sinc function of ft. Sinc function of ft. How I got it? How I got it? The Fourier transform of this pt is expressed by this one. How do I got it? I got it from its original signal, which was the xt, by characterizing this xt. Remember, the x f. Now imagine this is a time domain signal xt. I want to convert it to the Fourier. How we convert it? Fourier. So time domain is converted to the frequency domain. So I will multiply it with e to the minus j 2 pi ft, integrate it over the minus infinity to plus infinity. This expression will give me the Fourier of xt. The time domain signal will convert to the frequency domain signal. Right? In our case, what is this xt? Xt is nothing but the signal pt actually, right? ptt. So our signal will be j2 pi ft, integration over minus infinity to plus infinity. So guys, this expression, how I express a time domain signal to a frequency domain to convert to the Fourier, this has to be done, or you have to have this knowledge of your analog communication signal, analog communication course. If it's not, then you have to go back, just review your previous courses. There you will find how to do this one. Okay, because this is our first class, I will show you how. Next time this silly stuff will not be repeated actually. Okay guys, now I want to convert this signal xf, which is actually in our case minus infinity to plus infinity. Our signal is pt e to the minus j 2 pi ft. This signal will be expressed by whom? This signal will be expressed by, imagine, what is this signal actually, right? This is a pulse. This is a pulse. This pulse has a height 1 minus t by 2, t by plus 2 by 2 with the duration t, right? Right? So e to the minus j 2 pi ft. I will here one of the knowledge from Euler's equation will be helpful. Euler's formula or Euler equation. What is the Euler equation? E to the power j theta. What is the e to the power j theta? Cos theta plus j sin theta, and e to the power minus j theta equal to cos theta, minus j sin theta, right? How this Euler equation gave us this idea, guys? This is how. You see, we can have our real real and imaginary axis, where we have a value at a certain point. Okay, so what is this value? There is e to the power j theta. That is the one we are looking for. So here this is actually, so this amount is cos theta, because this is a theta. So this is a cos theta. This amount is sin theta. So e to the power j theta will be cos theta plus j sin theta. This one. Okay, so substitute everything, minus infinity to plus infinity. What is a PT? The amplitude is 1. Yeah, amplitude is 1. Pulse, this is the amplitude of the pulse, 1 unit of pulse, and e to the power minus j 2 pi f t dt. Okay, got it, guys? Okay, so integration of e to the power minus x. What is the integration of e to the power minus x? Is e to the power minus x, e to the power minus j 2 pi f t. Remember the differential formula? E to the minus x will be actually e to the x equal to e to the power x. So e to the x, but this is minus. So punishment, we have to give the punishment to the minus j 2 pi f. So d by dt, t will be 1, right? This portion will be 1. So we are not writing it, which has a limit value plus t by 2 to minus t by 2. This is actually our duration, t by 2 to this is the limit. Remember? Now, so how we got e to the minus j 2 pi f t? We put it the value, e to the power minus j 2 pi f t will be t by 2 minus e to the power so minus minus so what is happening, we are putting replacing this limit, yeah, minus e to the power, so minus and minus plus e to the power j 2 pi f. So it was actually what, minus j 2 pi f minus t by 2, minus t by 2. So minus minus plus, so we can remove this minus. So j, sorry, j 2 pi f t by 2. Of course, j 2 pi f remains. Got it, guys? So what's happened? So e to the power minus j 2 pi f t, e to the power minus j 2 pi f t, e to the power minus e to the power j theta. So e to the power j theta. Imagine this one. So cos theta minus j sin theta. So this will be cos theta. This term will be cos theta minus j sin theta. And this term will be minus e to the power. So minus cos. Because of this minus, this one will be, this will be minus. So that's cos and this cos will be crossed. And j will be, this will be minus. So this minus and this minus, we will have 2 minus 2j sine 2 pi f t by 2, and minus j 2 pi f. So 2j and 2j cross. So these two cross. What we have? We have sine pi f t by pi f. To make it similar, pi f t by pi f, so we have pi f t, because we multiplied by t, I mean, so we will have another t, so they can be balanced. So you see, what is that? Sine x by x function, which is actually t sinc function, right? this is how we actually got this formula. This one. I have just shown you the solution. That how we can have sinc function. Okay, guys. So what we have? We just shown that, okay, if we have a time domain signal, we want to convert it to its Fourier frequency domain. That's actually the expression of this signal. Okay. Now, where we are now. So what is the average value of AK signal? AK, we can write it as a expected value of AK. What is the expected value of AK? What is the expected value of AK? Now we know P, that our pulse, which is can be expressed as AK. So the probability of AK is either A or minus A. What is the probability of AK? That its value is A is half. What is the probability of AK? That its value is minus A is half. So we need this idea of probabilities knowledge, because AK is random. Why we are looking for the probability? Because the AK is a random value, right? So the probability of this random is half and half. What is the expected value? So what is the expected value? The expected value is A into probability of AK when AK equal to A plus another amplitude is minus A into probability, that is AK value will be minus A, right? So A into half plus minus A into half is 0. So the expected value or the average value of this random AK is 0. Here we have an assumption that AK is IID. IID means independent, identically distributed. Identically distributed. They're independent. It's a two probability. Either it have a probability that it can be plus A, it can be minus A. So it's a independent, but it have an identical distribution. What is the identical distribution? A distribution half, distribution of half. Condition that. So what is the expected value of AK and AM? Another 2-bit AM. It has two probability, right? Identical distribution. So identical distribution means each takes minus or plus with half probability. And independent means basically these random variables are independent. Okay. So what is the expected value of AK and AM? So the expected value of AK. So there are 2 digits, AK, and imagine there are another digit, another bits. What is the expected value of these 2 digits? They are independent. We say they are independent, so we can write them independently. Pkam. Here the condition that k is not equal to m. So here expected value of ek is 0, expected value of em will also be 0, means this total value will be 0. Right? Okay. So we can write expected value of x t. What is that expected value of xt? The complete signal. We're writing the expected value of the complete signal is this one. We're writing x, this one, this signal xt. What is this signal? This one. So what is the expected value of this signal? Expected value of this signal will be it's nothing but the previous signal. I'm writing nothing but the previous signal. Since this value we just seen it, this value equals to 0, means the expected value of xt will be 0. Now what does it shows? It shows the expected value or average value. We see the average value of transmitted signal xt is 0. This is the average value that we concluded, right? Okay, so let's see if we can finish it here. How long time passed, I don't know. Let us stop here and again we will start recording.